Good morning. This lesson is going to cover gram-to-gram stoichiometry. What gram-to-gram stoichiometry is taking a given amount of grams of a substance in a chemical reaction and using the mole-mole ratio to convert it into grams of a different substance. Maybe you know how much of one reactant you have, and you need to calculate how much of a second reactant you will need. Or perhaps you know how many grams of one reactant you have, and you would like to know how many grams of product that will form. So this is going to make use of all of the other molar conversions that we have learned how to do. So be sure that you've got your calculator, your periodic table, and your notes page that accompanies this set of slides and this video. So when you're ready, go ahead and let's get going. First things, maybe. Okay. When we do stoichiometry, all of our stoichiometry conversions have to go through the mole. If we start with grams of a substance, we cannot do anything with it until we convert it into moles of that substance. That's what allows us to use that mole-to-mole ratio of products and reactants in a balanced reaction that we learned last week. Okay, so that's always going to be our first step, is converting whatever unit we have, grams or liters, and converting it into the mole. So you can't do any stoichiometry without going through the mole first. So let's look at what that is. Okay, the next slide is going to go through all of the pieces you will need to follow every time you make these kinds of calculations. After that slide, the remaining slides will go through examples of what those calculations look like. What does it look like when I complete these steps within a calculation problem? So let's get going. To complete grams to gram stoichiometry, these are going to be just like what we've done before. All of those conversion skills that we've learned, we're going to use here. The first thing that we're going to do is write out and balance our chemical equation. We can't do anything without a chemical equation. And it has to be balanced so that we have that ratio of coefficients. After we balance our chemical equation, what we're going to do is we're going to write the amount of material that we have above its chemical formula in the equation itself. The following steps that you see kind of filling in the screen here, these are the steps that we use for the calculations. As always, you're going to start with the given value, so that's going to be your first conversion factor. And we're going to convert whatever units were given in the problem, we're going to convert them into moles. Okay, so we'll look at examples of what that looks like, but the first step is always going from units of the given material into moles of that same material. The next thing that we're going to do is we're going to convert moles of that material to moles of the final material. This is where we're going to utilize that mole-to-mole ratio we learned last week. And the last thing that we're going to do is we're going to take those moles of our final material and convert them into grams, or we could use liters as well. It's just whatever final unit that the problem asks us to solve. So we're going to start with what we're given in the problem, usually grams. We're going to convert those grams into moles using our periodic table. Once we have moles of our starting material calculated, we're going to convert those into moles of the final material. That's using that mole-mole ratio from last week. And then lastly, we convert those moles of our final material into whatever unit we need, grams or liters. So here's an example. How many grams of ammonia are produced from 55 grams of nitrogen? So you can see here that this is a written equation, but it isn't yet balanced. And so our first step is going to have to be to balance the equation. So here we've got our balanced equation. Remember, there's an understood 1 in front of the nitrogen. So my ratio is 1 mole of nitrogen to 3 moles of hydrogen to 2 moles of ammonia. If we happen to be working with liters, if these were all gases, which they are, if these were gases, it actually works the same with liters. This would be 1 liter is is equal to 3 liters of hydrogen to produce 2 liters of ammonia. It doesn't work that way with any unit other than moles and liters. No other unit would the ratio apply to, okay? So once we've written our balanced equation, the next thing we're going to do is we're going to write above the material how much I have. So my problem, okay, stated that I had 55 grams of nitrogen. So I'm going to put that 55 grams of nitrogen above the symbol or the formula for nitrogen in the equation, and I'm going to put a question mark and the unit above what I'm looking for. So my problem said how many grams of ammonia are produced from 55 grams of nitrogen. 55 grams of nitrogen here, question mark, grams of ammonia. Notice there's nothing above our hydrogen. I don't need to use hydrogen in this equation, so I leave it blank. It is not part of this problem. All right, the next thing that I'm going to do is I'm going to get started with my given value. The only place I have to begin is with the 55 grams of nitrogen. So that is going to be my starting place. So I've got 55 grams of nitrogen, and if my screen will cooperate, you can see at the bottom we're going to start with our given value. All right. Calculation first step is we're going to convert that starting material, that 55 grams of nitrogen, to moles. Okay, our 55 grams is not moles, so it has to be converted. So my first step is to take my beginning amount, 55 grams of nitrogen, remember that was in the problem, and I'm going to convert it to moles. Okay, I do that the same way we always have. Okay, I know that 1 mole of nitrogen is equal to 28.02 grams. That comes from the periodic table. The grams of nitrogen are going to cancel. Remember, what I'm canceling goes on bottom, and what I want to calculate goes on top. The next step is our converting from moles of nitrogen to moles of ammonia. And this is where I'm going to use my mole to mole ratio. The mole to mole ratio comes from the coefficients in the equation. I know for every 1 mole of nitrogen, I will produce 2 moles of ammonia. So my next step is to use the mole-mole ratio to convert from the nitrogen in the equation to the ammonia in the equation. Looks like this, I hope. There it is. So my moles of nitrogen cancel, and the moles of ammonia are on top. Okay, this is my mole-mole ratio. Continuing on, this is what we've got so far. Remember that we canceled our grams of nitrogen and converted to moles. And then the next step, we used our balanced chemical equation to convert from moles of nitrogen here to moles of ammonia on top. Since the problem asked us to convert to moles of ammonia, that's going to be our final step. So our final step is going to be to convert these moles into the final unit. For this problem, we're going to go to grams. So 1 mole of ammonia on the bottom cancels moles of ammonia here, and that converts to grams of ammonia on top. Now this 17.04, remember that comes from the periodic table. Nitrogen is 14.01, and there are 3 hydrogens at 1.01. 17.04 is the total if you add them together. So those are my 3 steps in the calculation. I convert the grams of my starting material into the moles. Step 2 is I use the mole-mole ratio to change from what I have to what I want on top. And the final step was to convert moles of my final product into grams of that same material. Okay, that's all we did. Once we've converted converted into moles in our calculation. Now we can do the math. I take 55, notice I've got my parentheses here, 55 times 2 times 17, multiply everything across the top in the same set of parentheses, divided by anything on the bottom, 28.02 times, in this case it's a 1, so I don't really need to complete that. Close my parentheses, and I will be able to calculate my answer. You should calculate 66.9 grams of ammonia. So these calculations are using all of the little pieces we've learned along the way into a larger calculation. Simply converting from grams to moles, using our mole-mole ratio, and then converting back to grams. The same would apply if we were working with liters. We would just use a different factor. So let's try a second example.